Hello and welcome to the Creating a Basic Structure in GenFEA. In this tutorial, we'll be using the built-in modeling tools to create a portal frame structure similar to the one that you currently see on the screen. The workflow includes creating a new project, adding materials and sections to the project, adding design groups to the project, working with rotated grids and planes, modeling the portal frame structure using the modeling tools and editing tools, adding analytical components such as supports, load cases, and loads, and finally running and viewing the analysis. Let's start with creating a new project. To do this, we're going to click on the Create New Project button in the Welcome screen, and we'll specify the project title and the project location. So we're going to click on Create New Project. I'm going to call this one Basic Portal Frame Tutorial. We will set the location to Brisbane, Australia. I'll just type Brisbane and hit search. And then I'm going to double click on a location in the interactive map to place my marker point and to locate the correct address. When I click on OK, I can see the units are already set to millimeters, which is what we'll be using for this example, for this tutorial, so that's all fine. Now we've set up our project, let's look at the next step, adding materials to the project. To do this, we're going to click anywhere in the input workflow sheet, any cell, to display the materials contextual ribbon. We'll navigate to the materials sheet, and then from the material database, we'll be adding the material called S355. So I'm going to click on any cell in my input workbook. I'm going to select the drop-down and choose materials. Notice I can also use the cycle buttons to cycle between the sheets, or from the bottom, I can select on the appropriate tab. We're going to click on OpenDB, and I'm going to select any cell in the row of S355 and click on Add to add it from my material database into my project. We're going to do the same for adding sections to the project. We'll be adding 3 section types, 1 universal column, 1 universal beam, 1 cold form lip channel. The same principles apply. I'm going to cycle to the section sheet, click on OpenDB. From the universal column sheet tab, I'm going to select the desired column to import. I'm going to do the same for universal beams parallel flanged. And I'm going to cycle to the cold formed libz tab, and I'm going to select the one that I would like to bring in for my purlin sections. We can close the database once we're finished with it because we brought those sections into the model, so we don't need to have them active anymore. Next, we're going to create 3 design groups. 1 named columns with the color blue, 1 named rafters with the color cyan, and 1 named purlins with the color magenta. So we'll start. From the groups sheet, we click on Add. The first one is called Columns. The color is blue, and we're going to choose Apply and New from the Apply drop-down since we want to add another group. This time, Rafters. The color is going to be cyan. Apply and New. Then purlins with the color magenta. And this time we just click on Apply to finish the command since we've added all the design groups that we wanted to add. Next, we'll be rotating the grid. We're doing this because when rotating the grid in GenFEA, it also becomes the active working plane. So to do this, click anywhere in model space to activate the model ribbon tab, or simply just click on the model ribbon tab menu in the ribbon. Then we click on grid settings, we go to rotation, we change the axis to the y-axis, and we leave the default angle, rotation angle is 90. When we click on rotate, it rotates the grid in 3D space, as you can see here with the reference UCS icon, but it is also setting this to the active drawing plane in GenFEA. So when we start drawing, it's going to be drawing onto that plane. So let's look at starting to model our portal frame structure. In GenFEA, when adding frame elements in model space, you can do this by selecting the Draw Frame tool from the Model Ribbon tab, or by right-clicking in model space and from the contextual ribbon selecting Draw Frame, or you can use the keyboard shortcut F as long as model space is activated. That means clicking anywhere inside model space to make sure it's the active workspace or the active control. From the right-click context menu in model space, you've also got some snap options such as grid, endpoint, midpoint, or joint. There's some tools that we'll be using for cleaning up nodes, discretizing elements, renumbering elements, fixing the orientation, and updating the model. So let's look at creating our first half of the portal frame structure. We're going to draw half of the portal frame because we're going to be working on that and then mirroring it across to not have to duplicate work. So from here, you can see what the kind of structures that the general layout of the structure that we want to create and how many of these grid intersections we need to include in our modeling. So we've got 4 grids here before the first column, 3 grids before the next one, and then we've got 2 rafters for the first step. So let's model that now. I'm going to right click and choose draw frame. I can see from the contextual frame elements ribbon, it says the groups as columns, which is the first one in our list of design groups, which is correct. And the section is the universal column, so that's correct. I'm not going to change anything there. Then I'm going to count 4 squares, and I'm going to start drawing in my first column. I'm going to repeat that for the second smaller column, which I place over there. Next, we're going to change the groups to rafters, change the section size, and we're going to draw in our first rafter. For the second rafter, I'm going to snap to the endpoint of that column, and I want to snap to the intersection right here under my mouse cursor. But GenFEA is snapping to the endpoint of the column instead. So I'm going to right click, I'm going to uncheck endpoint snaps, and I'm going to make sure that it snaps to the grid intersection. Now that this is done, we want to reset our grid back to the XY plane. We're going to do a box selection of the frame we just created, and we are going to create an arrayed copy across the model. So we go back to grid settings, we go to reset grid, and from here we're going to choose the box select tool, and then we're going to choose copy. From copy, we're going to enter an X offset value of 5000, and I'm going to hit apply 3 times to create 3 additional portals, resulting in 4 total portals and 3 bays. When that's done, I'm going to click on the finish button to deselect all the elements and finish the command. Right, next we're going to draw the purlins between the rafters using the endpoint snaps and midpoint snaps, as shown in the first image. We're going to snap to the endpoints of the rafters and create the purlin elements. Then we're going to discretize the model so that the rafters are split by the intersecting purlins and separated into segmented bars. Once we've got that, we can snap to those midpoints again and create the remainder of the purlins. I'm going to show you what that looks like. Okay, so we're going to draw a new frame. We're going to make sure that we select the correct design group, purlins, and that we've got the correct section selected. Then I've unselected my grid snaps and I've selected my endpoint snaps to snap to the endpoints of my rafters. Now I'm using the endpoints to draw in the purlins as shown on the screen. Then I'm going to change to midpoint snap, and I'm going to repeat the process to create the purlins in the centers of the rafters. Once this is done, I'm going to right click and choose discretize elements. When we discretize elements, it splits the elements between intersecting elements. So the purlins are now segmented as well as the rafters at those intersections, which is what we want. Once it's done, it means that we can now again add purlins between the new midpoints of the split frame elements. You can use the shortcut key F to repeat the frame command if you don't want to use the context menu. Now that I've added all the purlins, again, I'm going to choose discretize elements. I'm going to right click and choose clean nodes. Right click again and choose renumber elements. Right click again and choose fix orientation. And finally, I'm going to choose update the model to make sure everything is refreshed and renewed in model space as well as my input workbooks. The next step is to create a mirror version of the portal, and we're going to be selecting the appropriate elements to achieve that. First, we need to set the grid again to rotate 90 degrees about the y-axis so that we're working on the correct plane. I'm going to change my view from perspective to ortho mode. I'm going to use the cross selection tool to cross select the elements I want to mirror. And look, I'm careful not to include the purlin elements here in the center at the top of the frame, because if I duplicate them, they will be overlapped with each other. So I use the cross selection button to create a cross selection and crossing all the elements I want to include and also all the elements within the box that should be included. Once I've got my selection, I can press the M key on the keyboard, or I can click on mirror in the ribbon to create my mirror. Now I need to specify 2 reference points. So I'm going to right click and choose grid so I can snap to grid intersections. And I'm going to choose 2 reference points on this red axis as my mirror line. The program will now create the mirrored components, and it should only take a few seconds. Right. Once that's finished, I'm going to switch my ortho mode back on again. I'm going to go to grid settings and I'm going to reset my grid back to the XY plane. I'm going to run through the process again of cleaning up nodes and renumbering elements and fixing the orientation, and finally updating the model, making sure that everything looks fine. At this point, you can click on Show Labels from the Model ribbon tab and make sure that you don't see any overlapping text on the nodes, the red ones, or for the beams, the blue labels. Everything here looks fine. The logic, the sequencing of the numbering looks logical, and everything looks tidy. So we should be good to go on to the next step, which is going to be adding the supports. Adding supports is quite simple. I'm going to activate a view that allows me to do a box selection of all the base nodes in the model which are going to serve as my supports. Then I click anywhere in my input workbook and I change the active sheet to nodes. From here, I'm going to click on edit and I'm going to check all the boxes under translation and also for rotation and hit apply. You'll see it's now added some properties here in the input workbook next to the fixity for translation and rotation columns. I'm going to click anywhere in model space to deselect elements, and I'm going to unselect the box select action. Next, we'll add a load case. So I'm going to click again anywhere in the input workbook, change my active sheet to load cases, and I'm going to choose add a load case. I'll leave the name as LC1, the default, and I'm going to choose the option to contain self-weight and hit apply. We'll only add a single load case for this particular tutorial. In future tutorials, we look at multiple load cases and load combinations. For now, we've got a single load case called LC1, and it contains the own weight of the structure. Next, we're going to be adding some loads to the purlins. So again, I'm going to rotate my view so I can have an easier access to selecting my purlins. I'm going to use the cross select, and I'm going to carefully create a cross selection box to select all the purlins in the bay you see there. I'm going to hold in the control button and repeat that so that I can add to the current selection. Again, I'm holding in the control button and doing cross selection in this remaining bay as well. When I rotate the model, I can see all the purlins are selected. From here, I click anywhere in my input active workbook. I navigate to my loads sheet and I click on the add dropdown and select line load. From here, I'm going to add a value for FZ as minus 0.3 and I'm going to hit apply. Click anywhere in model space to deselect the selected elements and exit the cross selection action. Now we are ready to run the analysis. To run the analysis, we have to make sure that when we select anywhere in any sheet in the input workbook, that analyze and display options as well as parse is selected. Then we click anywhere in model space and we choose run all. This will run through all of the analysis cases and it will produce the results, and it will also then read the results back into GenFEA. From here, we can see that we've got a solid model now. So it's extruded the cross sections along the beam elements, the framing elements. And when we click on model space, it displays the results ribbon tab as opposed to the model ribbon tab. From here, we can choose to switch on deflections. If we click on the animate button, you'll see that it starts animating the deflection by exaggerating the scale of the values. And I'll just click that again to stop it. We can switch on the actual values. We can switch on Y and Z shear, torsion, Y and Z moments. And of course, any of these values or results can be amplified by just using the amplification scroll, or you can scroll with your mouse wheel in the text box, or you can use the up and down buttons, whichever works best for you. You can also switch on your support reactions. By default, when I click on supports, all three directions are displayed. I can isolate only the Z direction if I want. And again, I can magnify that or amplify that as necessary. The support reaction symbols are drawn according to the magnitude of the result. So you'll see the length of the arrow is directly connected to the reaction value. And for X, Y, and Z directions, it'll display to me the force as well as the moment. So we can toggle between what we would like to display and what we want to see in the reactions. We only have a single load case. If we had more and load combinations, we'd be able to select them from the list also. Now, from model, we can go and show the support symbols. This is what they look like. They are colored by support direction. The triangle means that particular node is fixed for translation in the direction, so the pyramid. And then the small box added to the back is indicating that it's also fixed for rotation. We could also switch on the load symbols now. We've got linear loads in this model, no point loads. And of course, we can scale the results by using the symbol size amplification value here in the ribbon. Right, and that concludes today's tutorial on creating a basic portal frame using the built-in modeling tools in GenFEA. We look at more complex structures and defining custom end releases such as torsion pinned or just normal pinned end releases. We look at load combinations and multiple loads within the same model and different types of analysis than the static analysis that we used in this basic tutorial. Thank you. I hope that you found that information useful and see you in the next tutorial. Goodbye.